Okay, walk. Episode 1, Activity 5.3, Making Sense of the Constant P. You have learned that standards of the parabola with the vertex at the origin is the equation in the form x squared equals 4py or y squared equals 4px. Where p represents the distance from the vertex of the focus, what is the significance of the value 4p in each equation? So the vertex is the point 0, 0, which is here. The focus P0, which is here. And the directrix, which is x equals negative p, which is right here. All right, go and finish that up. The distance from the focus to the directrix in this graph, the distance from the focus to the directrix is 2p. Let's take a look at the next page. Write an equation for the parabola. Let d represent the distance from the point Q on the parabola to the focus. Write an equation using the distance formula to represent d1. Simplify the equation. Okay, so this is x2, this is y2, this is x1, this is y1. So we're going to plug these into the distance formula. So that's d equals x minus p squared plus y minus 0 squared, which equals x minus p squared plus y squared. Right? Line segment QR represents the perpendicular distance from point Q on the parabola to the directrix. Draw a line segment QR. What are the coordinates of the point R? Label the coordinates on this graph. So the coordinate point R is negative p y. C. D2 represents the distance from point Q to point R. Write an equation using distance formula to represent D2. Simplify. So we have Q and R. So this is x2, y2, x1, y1. We're going to plug these into the distance formula. So that's D2 equals x minus negative p squared plus y minus y squared, which simplifies to be x plus p squared plus 0 squared, which equals the square root of x plus p squared. D. Write an equation for the parabola using parts A through C. Simplify the equation so that one side of the equation is the squared term. So D1 is equal to x minus p squared plus y squared equals the square root of x plus p squared. Now to solve, these have both square roots, so you're going to square both sides. The squared cancels the square root, so you're left with x minus p squared plus y squared equals x plus p squared. So we're going to subtract x minus p squared from both sides. That cancels. You're left with y squared equals x plus p times x plus p minus x minus p x minus times x minus p. So y squared equals x squared plus xp plus xp plus p squared minus x squared minus x xp minus xp plus p squared. So y squared equals x squared plus 2xp plus p squared minus x squared plus 1xp plus 1xp minus p squared. Now, x squared minus x squared cancels. P squared minus p squared cancels. So you're left with y squared equals 2, 3, 4xp. Okay, go ahead and finish that up. All right, let's take a look at the next page. Activity 5.4, using the constant p to graph a parabola. Let's investigate different equations to understand the relationship between the structure of the equation and its graph. Consider the parabola represented by the equation y squared equals 20x. Identify the coordinates of the vertex in the equation of the line of symmetry. So to do this, we're going to graph this. So we're going to go to Desmos. We're going to graph y squared equals 20x. So the parabola is 0, or vertex is 0, 0. So the vertex of the parabola is 0, 0. The axis of symmetry is y equals 0. Okay. Determine the value of p, then determine the coordinates of the focus in the equation of the directrix just by reasoning. Okay. We know that y squared equals 20x, y squared equals 4px, so 4p equals 20, so p equals 5. So the value of p is 5. The coordinate of the focus is 5, 0. The focus is 5 units from the vertex. Graph the parabola, then describe the concavity of the parabola. Justify your reasoning. So we know the vertex is 0, 0. Let's find a point. I'm going to zoom out a little bit. Oh, looks like 5, 10 is a good point. So 1, 2, 3, 4, 5, 10. If 5, 10 is a good point, we know that negative 5, 10 is a good point. Okay. We know that the focus is 5, 0. So 1, 2, 3, 4, 5. That means the directrix is 1, 2, 3, 4, 5. The parabola is concave right. The parabola opens towards the focus and away from the directrix. All right, go ahead and finish it up. Let's take a look at the next page. Let's take a look. Consider the parabola represented by the equation x squared equals negative 12y. Let's find the vertex and the axis of symmetry. So we're going to come over here. X squared equals negative 12y. So our vertex is 0, 0. So the vertex of parabola is 0, 0. The axis of symmetry is x equals 0. Determine the value of p, then determine the coordinate of the focus in the equation of the directrix. Justify your reasoning. We know x squared equals negative 12y, x squared equals 4py. So 4p equals negative 12. So we're going to solve for p. So we divide both sides by 4. So p equals negative 3. So the value of p is negative 3. The coordinate of the focus is 0, negative 3. The focus is negative 3 units from the vertex. Okay, now to graph the parabola, then describe the concavity of the parabola. Justify reasoning. Well, we know the vertex is 0, 0. Let's find a point. I'm going to go to the home screen. Negative 5, negative 2.03. We can 83. We can approximate to negative 5. Negative 2 is probably our best point. So let's do that. So negative 1, 2, 3, 4, 5, negative 2. And if you do negative 5, negative 2, you can do 1, 2, 3, 4, 5, negative 2. Okay, our p-value is 1, 2, 3. And so 1, 2, 3. The parabola is concave down. The parabola opens towards the focus and away from the directrix. All right, let's take a look at the next page. Student works 3A, 3B, and 3C. All right, let's take a look at the next page. Student works 4A, 4B, and 4C. All right, let's take a look at the next page. Analyze each equation and its corresponding graph in question 1 through 4. Describe the relationship between the sign of the constant p and the concavity of each parabola. When p is positive, the parabola is concave up or concave right. When p is negative, the parabola is concave down or concave left. All right, go ahead and complete the table. All right. Let's take a look at the next page. Activity 5.5, writing an equation given a focus and directrix. In this activity, you will use the distance formula to determine the equation of points that are equidistant from the given point, the focus, and a given line, the directrix, where the vertex is a point other than the origin. So we're using the distance formula. We're determine the equation for all the points equidistant from a point -3, -5, and the line y equals 3. So this is going to be x2, y2, x1, y1. This is x2, y2, x1, y1. Okay, so we plug these into the formula. So that's the square root of x minus -3 squared plus y minus -5 squared equals the square root of x minus x squared plus y minus 3 squared. So that becomes the square root of x plus 3 squared plus y plus 5 squared equals, this becomes 0, so then you're left with square root of y minus 3 squared. Now, we're going to square both sides. That cancels the square root on both sides, and then you're left with x plus 3 squared plus y plus 5 squared equals y minus 3 squared. So we're going to subtract y plus 5 squared from both sides. So then you get x plus 3 squared. That cancels, equals y minus 3 squared minus y plus 5 squared. Now, I ran out of room on the paper, so I'm going to have to add some paper to this. So I'm going to do that here. So then this becomes, we're just going to leave this as x plus 3 squared equals y minus 3 times y minus 3 minus y plus 5 times y plus 5. So x plus 3 squared equals y squared minus 3y minus 3y plus 9 minus y squared plus 5y plus 5y plus 25. So then you get x plus 3 squared equals y squared minus 6y plus 9 minus y squared minus 5y minus 5y minus 25. Well, y squared minus y squared cancels. You have x plus 3 squared equals negative 6 minus 5 is negative 16y. 9 minus 25 is minus 16. So then you have x plus 3 squared equals, I'm going to factor out a negative 16, which leaves y plus 1. All right, go ahead and finish writing that up. So the vertex, which we can just look at the graph, which is right here. So negative 3, negative 3, negative 1. So the axis of symmetry is x equals negative 3. All right, let's take a look at the next page. All right, again, there's a distance formula. Consider the graph. Determine the equation for all the points equidistant from point 75 in the line x equals 1. So this is, again, x2, y2, x1, y1, x2, y2, x1, y1. So we plug into the distance formula. So then that's x minus 7 squared plus y minus 5 squared equals square root of x minus 1 squared plus y minus y squared. So we have the square root of, almost forgot. Square both sides. Cancels. You're left with x minus 7 squared plus y minus 5 squared equals, that cancels. You're just left with x minus 1 squared. So subtract x minus 7 squared from both sides. You're left with y minus 5 squared equals x minus 1 times x minus 1 minus x minus 7, x minus 7. Okay, so we have y minus 5 squared equals x times x is x squared minus 1x plus 1 minus x squared minus 7x plus 49. And run out of room, so we're going to add some paper here. So then that's y minus 5 squared equals x squared minus 2x plus 1 minus x squared plus 7x minus 49. Well, the x squareds cancel. You have y minus 5 squared equals negative 2 plus 7 is 12x. 1 minus 49 is minus 48. Factor out of 12, you get y minus 5 squared equals 12, parentheses x minus 4. Okay, go ahead and finish that up. All right, let's take a look. Determine the coordinate of the vertex. That's easy. We can look at the graph. That point is 4, 5. So the axis of symmetry is y equals 5. let's take a look at the next page. Rewrite each equation in standard form. Determine the value of P, the coordinate of the vertex and the focus, and the equation of the directrix and the axis of symmetry. Then sketch the graph of the parabola with the focus and directrix and describe the concavity. So we need to subtract 8x and 16 from both sides. So then we get y squared plus 8x equals negative 8x minus 16. Now we need to complete the square here. So we're going to add 8 divided by 2 squared to both sides. But what you do to one side, you have to do the other. So that's plus 8 divided by 2 squared. So then you have y squared plus 8x plus 8 divided by 2 is 4 squared is plus 16 equals negative 8x minus 16 plus 16. Well, this becomes y plus 4 times y plus 4 equals, those cancel, negative 8x. So y plus 4 squared equals negative 8x. All right, let's go ahead and graph that. So vertex is 0, negative 4. And let's see if we can find a point. Negative 2, 0 is perfect. So if I go up 1, 2, 3, 4 to the right 2, I can go down 1, 2, 3, 4 to the left 2. And there's our parabola. Now, we know that 4p equals negative 8. So p equals negative 2. So there's your p value. And so then 1, 2. Okay. So the vertex is 0, negative 2. The p-value is negative 2. Oh, I'm sorry. The p-value is, yep. And the axis of symmetry is y equals negative 4. I'm sorry. Vertex is 0, negative 4. All right, let's take a look at, finish up that. Let's take a look at the, all right, so here we're going to divide everything by 4. So that becomes x squared minus 10x plus 12y plus 1 equal to 0. We're going to subtract the 12y minus 1 from both sides. So you get x squared minus 10x equals negative 12y minus 1. Complete the square. So plus negative 10 divided by 2 squared to both sides. So you get x squared minus 10x plus negative 10 divided by 2 is negative 5 squared is plus 25 equals negative 12y minus 1 plus 25. This factors to be x minus 5 equals negative 12y plus 24, which then is x minus 5 squared equals negative 12y minus 1. All right, let's go ahead and graph that. All right, our vertex is, it looks like 5, negative 1. And then a point, that doesn't look like a good point. We need to go points. -1, -4. Okay, so if we go 1, 2, 3, 4, 5, 6, down 1, 2, 3, 1, 2, 3, 4, 5, 6, down 3. Now, to find the p-value, we know that 4p equals -12. So p equals -3. So the p-value is -3. The vertex is -1, 2, 3, 4, 5, -1. So the axis of symmetry is x equals -5. All right, go ahead and finish that up. All right, let's take a look at the next page. All right, write an equation in standard form for each parabola, then graph, then label the parabola. Well, the parabola, the vertex, so we know this is h and k, and the focus is 3, 4. So h and k is 3, 2. The focus is 2 units above the vertex, so p equals 2. So our vertex is 3, 2, so 1, 2, 3, 1, 2. So our equation is x minus 3 squared, which equals 4 times 2, y minus 2. So x minus 3 squared equals 8, parentheses y minus 2. So we can go and graph that. Parentheses x minus 3 squared equals 8, parentheses y minus 2. So our vertex is 3, 2. We have a point -1, 4. Okay, so we go 1, 2, 3, 4 up 2. 1, 2, 3, 4 up 2. Our p-value is 2 units above the vertex, so 1, 2. So then there's your y equals 0. All right, go ahead and finish up 5a. All right, student work 5b. Go ahead and complete the table. All right, let's take a look at the next page. You can mark off this page. You can mark off this page. Student works 1 and 2. Student works 1, 2, 3, 4, 5, 6, 7, 8. 1A, 1B, 1C, and 1D. And student works 3A, 3B, 3A, 3B, 4A, 4B. All right, go ahead and start working on your assignment and have a wonderful Wildcat day.